Now let's do some numericals which are based on echo. First, an observer stands at a certain distance from a cliff and produces a loud sound. He hears the echo of the sound after 1.8 seconds. Calculate the distance between the cliff and the observer if the velocity of sound in air is 340 meter per second. So here you are told the velocity of the sound and you're told the time in which echo is heard. You just need to calculate the distance. So we all know that distance is given by what? Distance will be equal to velocity into time upon 2, isn't it? So here the velocity is 340 meter per second. Time is 1.8 divided by 2. The distance is coming out to be 306 meter. This was a simple numerical. Let's see another one. A person fires a gun while standing at a distance of 850 meter from a building. That means the distance between the gun and the building is 850 meter. If the speed of sound is 350 meter per second, calculate the time in which the person hears an echo of the gun shot. You simply need to calculate the time. So we need to change the subject. So you know that time will be given by 2d upon v, isn't it? Since v is equal to 2d by t when we use it for the echo. So t will be equal to 2d upon v. So 2 into 850 divided by 350. This gives you 4.86 second. That means you will hear an echo after 4.86 second. The next numerical. A pendulum has a frequency of 5 vibrations per second. An observer starts the pendulum and fires simultaneously and he hears the echo from a cliff after 8 vibrations of the pendulum. If the velocity of the sound in air is 340 meter per second, what is the distance between the cliff and the observer? Now, children, this is an interesting numerical in which the time is not given to you directly. The time is given with respect to a pendulum. And he's saying a pendulum has a frequency of 5 vibrations per second. A pendulum is started, gun is shot, and the echo is heard after 8 vibrations of the pendulum. So this 8 vibrations of the pendulum, from this data you will have to calculate the time first. Now we are given that the frequency of the pendulum is 5 vibrations per second, isn't it? So time taken will be 8 upon 5 equal to 1.6 seconds. Okay. You can even do it by unitary method. 5 vibrations is equal to 1 second. 8 vibrations will be equal to 1 upon 5 into 8. This gives you 1.6 second. So you can use the unitary method to calculate the time taken. The velocity is given 340. So distance we all know will be given by velocity into time upon 2. So just substitute the values. 340 into 1.6 divided by 2. That gives you 272.0. Here the unit will be only meter. It is not going to be per second. So you have distance as 272 meters. A man standing between two cliffs produces a sound and hears two successive echoes at intervals of 3 seconds and 4 seconds respectively. Calculate the distance between the two cliffs. The speed of sound in air is 330 meter per second. So this question is saying that there's a person who's standing between two cliffs, right? Now, uh, obviously the sound will travel from him to both the cliffs, right? And will get reflected. Since he is obviously not standing in exactly the middle, so he'll hear echoes after different time intervals. First echo will be heard from the nearer cliff, and the second echo will be heard from the cliff which is further away. So let's say that this is one cliff, this is another cliff, there's a person standing over here, and this from here he hears the echo after 3 seconds, here after 4 seconds. So we can assume this distance to be d1 and this distance to be d2. So you know that if you want to calculate distance, then that will obviously be velocity into time divided by 2. So velocity is 330, right? And time is 3. So 330 into 3 divided by 2. This is giving you 495 meter. Next, when we apply the same formula to this side, then distance d2 will be 330 into 4 by 2. That means 660 meter. So the total distance will be d1 plus d2. That means 660 plus 495, that is giving you 1155 meter. Now the next numerical is a boy stands in front of a cliff on the other side of a river. He fires a gun and hears an echo after 6 seconds. The boy then moves backward by 170 meter and again fires the gun. He hears an echo after 7 seconds. Calculate first the width of the river and second speed of the sound. Now, see, this is when there is a river and a boy is standing over here, right? So we need to calculate the width of the river. Let's say the width of the river is x, right? Now he is standing, there's a cliff over here, right? And he's standing over here and he fires a gun. So he is hearing an echo after 6 seconds. Clear? So the velocity is given by 2d upon t. V will be equal to 2x because x is the distance that we have assumed and time is 6. So we have got one equation as V is equal to 2x upon 6. Now the boy moves back, right, by 170 meter. He is now over here at 170 meter. So what is the total distance? The total distance will be x plus 170. And he is hearing the echo after 7 seconds. That means we'll have, if we substitute it again in this formula, velocity is equal to 2d upon t. What will we get? V will be equal to 2 into x plus 170 because he's moved back. The distance is x plus 170 and the time is 7. Clear? Now the velocity of the sound in the first situation and the second situation obviously is the same. So we can equate this A and the B. When you equate these two, you will get 2x upon 6, right, into 2x plus 340 upon 7. Now you cross multiply, you get 14x is equal to 12x plus 2040, and from here you can calculate the value of x. So when you calculate the value of x, you have got the width of the river. And to calculate the velocity of the speed of the sound, you will substitute the value of x in this formula. V is equal to 2x upon 6. Over here, you could have, instead of this thing, you could have also done it in this way. 2x upon 6 is equal to 2 into x plus 170 upon 7. You could have directly cancelled this. So this would have become 7x is equal to 6x plus 0, right? So x is coming out to be 1020. Right? So this is the width of the river. And to know the velocity, velocity will be 2 into 1020 divided by 6. This will give you 340 meter per second.